Okay, in this video, we're going to solve this integral right here, and so let's begin. And I'll be honest, this problem is pretty intense. There's definitely a lot of steps, and so I have it typed out as opposed to me writing. And this is just one slide. So 1 plus x cubed, we can use the sum of cubes. So we're going to rewrite it as x plus 1 parentheses x squared minus x plus 1. Then we're going to use partial fraction decomposition. So I'm going to say a divided by x plus 1 plus, because this piece is an x squared, we'll get bx plus c divided by x squared minus x plus 1. Now we want to get rid of the denominator, so I'm going to multiply it by x plus 1 times x squared minus x plus 1. And when we do this, it'll be 1 times this stuff, which will cancel the denominator out, so we get 1 is equal to a times this piece plus bx plus c times this piece. Then we're going to expand, so we're going to distribute the a to all three pieces. Likewise, we're going to do bx times x, get bx squared, bx times 1, get bx, c times x is cx, c times 1 is c. From here, I'm going to group. So I have an x squared right here, I have an x squared right here, I'm going to group them. Then I have an x right here, an x right here, an x right here, I'm going to group that. And then I have the constant, a and c. From here, I'll develop my systems of equations. So a plus b corresponds to x squared. And on the left-hand side, there's no x squared, so is equal to 0. Likewise, negative a plus b plus c is equal to 0 because there's no x here either. And then the constant piece, a plus c is equal to, our constant here is 1. And now I'm going to move on to the next slide. So now I'm going to rewrite a plus b is equal to 0. I can say a is equal to negative b. And my second equation, negative a plus b plus c is equal to 0. I'm going to replace my negative a with positive b because it's like divide by negative 1, divide by negative 1. Negative a is equal to positive b. So I have b plus c is equal to 0. So 2b plus c is equal to 0. Then we have this piece, a plus c is equal to 1. And again, we said a is equal to negative b, so we swap. So negative b plus c is equal to 1. So we can say that c is equal to 1 plus b. By adding b here, that's how we get c is equal to 1 plus b. So I'm going to go back to this middle equation here. 2b plus c is equal to 0. I'm going to replace c with 1 plus b. So 2b plus 1 plus b is equal to 0. 2b plus b is 3b. 3b plus 1 is equal to 0. Subtract 1, 3b is equal to negative 1. Divide by 3, and so b is equal to negative 1/3. And once we know b, we can replace it. So a is equal to negative 1/3, so a is 1/3. Likewise, we can also get c. c is equal to 1 plus b. 1 minus 1/3 will give us 2/3. So that was a lot of work. And so now we're going to another page. So here all I did was swap. So I know my a, I know my b, I know my c. I'm swapping here. And from here, I'm going to split it up. So I have a 1/3, 1/3, 1/3. Let's just take out a 1/3. Do your integral. 1/3 times 1 is, 1/3. 1/3 times negative x would give us negative 1/3 x. 1/3 times negative 2, so positive 2. 1/3 times 2 is 2/3. So this and this equivalent. So now I'm going to split up the integral. So I'm going to get 1/3 the integral of this piece minus 1/3 the integral of this piece dx. From here, I'm going to pick this piece right here. I'm going to use u substitution. So if u is equal to x squared minus x plus 1, then our du would be 2x minus 1 dx. Problem is, this piece isn't 2x minus 1 dx. So we have to do a little bit of modification, and we're going to see that in the next slide. So this piece right here is a straight copy from the last slide. This is the new thing. So for right now, what I'm going to do is focus on this integral right here. Even ignore the negative 1/3. I'm just focusing on this piece right here. Now, if I take out a 1/2, I can do that if I double this piece because 1/2 times 2x is positive x. 1/2 times negative 4 is negative 2. So it's a match. Likewise, I can change negative 4 to negative 1 minus 3. Okay, we're going to continue. So now this is a copy from the last slide, and this is the new stuff. So now I'm going to split up this part even further. So I split up into two parts, 2x minus 1 here, and positive 1. How I got positive 1? I have a negative 3 times 1 is negative 3. So no changes. Now I'm going to focus on this integral right here. And for right now, I'm going to ignore this 1/2. Because this 1/2 is being multiplied everything here. So 2x minus 1 divided by this piece. Now this will be simple because of what we saw earlier. And this is what I mean. You know, if u is this, du would be 2x minus 1. And that's why that part's going to be very simple. This one right here, this negative 3 integral of this piece right here, that's going to be a pain, but it will be manageable. And so we're going to continue. So now I'm splitting it up. So this is the easy one I was saying. U is x squared minus x plus 1. Du is 2x minus 1 dx. And so 2x minus 1 dx, this piece right here, it gets to be changed to du. And this denominator gets changed to u. And the integral of 1 over u is ln, absolute value of u plus c. And we know that u is x squared minus x plus 1. So we have one part. Now for this part, which is more of a pain. So we know the integral of 1 divided by x squared plus 1 dx is equal to tan inverse x plus c. So I need to kind of modify this part. X squared minus x plus 1. So I'm like applying, completing the square. So x squared minus x plus 1, you know, doing completing the square, we're going to get this. Because you can kind of think about it this way. X squared minus x is like minus 1x. So negative 1. Negative 1 divided by 2 is going to give us negative 1/2. Then I square it and I get a fourth. So I'm adding a fourth here. I'm still going to keep my plus 1. And because I added a fourth, I need to subtract a fourth. And so focus on this piece right here. This is the same as x minus 1/2, close it, squared. And then 1 minus a fourth is going to give us 3/4. And you can always prove it to yourself. Let's expand it. X minus a half times x minus half is going to get you this. And so we have our negative 3, the integral 1 divided by x minus a half, close it, squared, plus 3/4 dx. Now, if I make x minus a half and I say that it's equal to 3/4 u squared, we'll see why I have to do that. Now, my goal is to get x squared plus 1. If I say that u is equal to x minus 1/2, I still have a 3/4. So I have to do something creative. I'm going to say that x minus a half, close it, squared, is equal to 3/4 u squared. And if I do that, I take the square root of both sides, I will get x minus a half is equal to, I'm taking the square root of the 3, I'm also taking the square root of 4. Square root of 4 is just 2, and the square root of u squared is u. So this to this, you know, equivalent. Now, I don't want to deal with a fraction, so I'm going to multiply the green part by 2. So I'll have 2x, and then negative 1/2 times 2 is just negative 1, and then this piece times 2, you get the square root of 3u. At this point, if I want to get u by itself, I can divide by the square root of 3, divide by the square root of 3, and this is what I get. So u is equal to this, and if I do the derivative, du is equal to 2 divided by the square root of 3 dx. And if I want to isolate dx, I can do times square root of 3 times square root of 3. That's why I have the square root of 3 in the numerator, and then divide by 2, divide by 2. And so at this point, now I'm going to swap. So instead of saying x minus 1/2, close it, squared, I'm going to say 3/4 u squared plus 3/4 times, instead of dx, I'm saying this piece right here. And now we'll continue. So this stuff right here is the same. I didn't do any changes. And this part we're continuing. And this first line is what we had in the last slide. So now what I'm doing is just cleaning it up. So this piece right here, I'm bringing it to the front, so nothing special. And then here, I'm getting rid of the 3/4. The reason I can do that is because I'm changing to this. The integral 1 divided by 3/4 parentheses u squared plus 1 du. And that's why I can take out this 3/4. So now we have this. In the next line, instead of having a fraction over fraction, I simplified and got times 4 over 3. And now u squared plus 1. So we saw, once you have in this form, 1 divided by x squared plus 1 is equal to tan inverse of x. So first, all of this stuff right here, it kind of cleaned up. You know, cancel the 3, cancel the 3. 4 divided by 2 is, 2. And you have your negative here. So this part right here is this part right here. And now 1 divided by u squared plus 1, we saw in the last slide, it's going to be tan inverse. In the last slide, it was x squared. Here we have u squared, so put u. And we saw that u was 2x minus 1 divided by the square root of 3. And so we swap it right here. Instead of u, we put this. Okay, so now we're putting it all together. So originally, this is what we had. And we said this piece was an easy piece that we will deal with at the end. And this piece was a complicated piece that had other parts to it. So 1/3 integral 1 divided by x plus 1. I'm going to go back and forth just to make sure everything is clear. So this piece right here we saw, and now this piece, negative 1/3. So here we have our negative 1/3 x minus 2, but we had to split it up, and we split it up here. And so this 1/2, it needs to come back. And that's why we have this 1/2 right here. And then 2x minus 1, this piece right here, we set it right here. Likewise, this piece came from here. That's how we get this part. And so now let's kind of clean it up. So this part right here, this integral 2x minus 1 x squared minus x plus 1, we saw it right here. That's how I got ln absolute value of x squared minus x plus 1. And then this piece, this was the pain piece, and we got it right here. So I'm just swapping again. And so now let's just clean it up. Negative 1/3 times a half is negative 1/6. A negative negative 2 is positive 2. We have to divide by 2, so the 2 cancels. Likewise, the square root of 3 divided by 3. It's right here. And so we can continue. And as a minor thing, as a super minor thing, x squared minus x plus 1, if you were to graph it, no matter the x value, the output will never be negative. And so because of that, if you want to get rid of the absolute value symbol right here, you can. And so finally, this right here is your final answer. So this was definitely a very involved problem. And if you want more practice, check out the description box for more videos.